One day we will become extinct. Think about it. No matter how near or how far away that day may be, if it is not catastrophic, if we slowly disappear, one day there will be only one human individual left. Just like the arrowbird, which we ruthlessly hunted to extinction for its colorful plumage and recorded the sad mating call of its last male, or the northern white rhinoceros, which is only two individuals left in the world since 2018 because we destroyed its habitat, and both are females, so it is practically extinct. And yet, as humans, we act as if we will exist forever. Because when we look at the 300,000-year history of our species and compare it to our own 80-year lifespan, the difference is so great that we feel like we have millions of years ahead of us. But statistically speaking, the average mammal lasts about 1 million years, and as Homo sapiens, we've already used a third of that. Of course, this is just an average. So maybe, unlike them, we really will be around for millions of years. But there is also the other side of the coin. Maybe our intelligence, which we rely on so much, will get us into trouble like no other mammal has ever faced, and we will die out even faster than the average mammal, as we are feeling the footsteps of now. We don't know because there are no civilizations to compare ourselves to. If there were, we could try to predict our own future by looking at how often those intelligent species went extinct, but we can still use what we know about the world and the universe to make some educated guesses about how we might end up. So today, let's take a look at some of the most likely and extreme scenarios, from micro-black holes to planet-killing meteors, gamma-ray bursts to alien invasions. But this planet we call Earth and our solar system will be long, long gone, long before the end of the universe. In fact, our sun has at least another 7 billion years to live. But stars are not stable things. They evolve and change throughout their lifetime. And as I'll tell you in detail in another video, the sun, which is progressing on the main sequence, is getting brighter by about 10% every 1 billion years on average. So about 1 billion years from now, its brightness will increase by another 10%. This number may not sound bad at first, but it is this brightness that determines the width and radius of the habitable zone that stretches like a ring around the sun. And a 10% increase in the sun's brightness will shift the habitable zone by tens of millions of kilometers, moving it out of the region of Earth's orbit and into the region of Mars. So the Earth's orbit will be outside the sun's Goldilocks zone, and this will bring massive destruction. Because of this increase in evaporation, the average temperature on Earth will rise rapidly, causing all the oceans to evaporate. Since water vapor is a powerful greenhouse gas, this evaporation will further increase the temperature on the surface, and the Earth will turn into a piece of rock not at all suitable for life, like Venus is now. Perhaps some single-celled organisms that can adapt to extreme conditions might survive. But this event will be one of the deadliest mass extinctions in the history of the world. As humans, with our current technology and biological limits, it is impossible for us to survive this event. Of course, humanity is not going to be left holding the bag for the next 1 billion years. But given the scale of the problem, we don't have time to waste. We need to go beyond just focusing on the problems on Earth and work towards becoming at least an interplanetary, and if possible, an interstellar civilization. Although many people think that Earth is the most habitable planet in the universe, this is not true. Earth is a very good planet for life as we know it, but it doesn't get 100 out of 100 points as people think. Rather, it scores around 82. Planets that are even more habitable than Earth are called superhabitable planets. And so far, we've found at least 22 exoplanets that are candidates for these. The problem is that the best candidates are about 3,000 light years away from Earth. So we'd better figure out how to travel at close to the speed of light as soon as possible. Because even if we accelerate our spacecraft, which can currently reach a maximum of 0.06% of the speed of light, to 99.99% of the speed of light, it would take 3,000 years on Earth to reach that planet. Of course, since time would slow down for a vehicle traveling at that speed, the astronauts there could reach that planet in only 42 years. But that 1 billion years is quite optimistic. To be honest, we'll probably be gone long before that, Because look around you. Can you see any alien civilizations? No. Why is that? If there's nothing special about human life, why isn't the universe teeming with intelligent civilizations? If you remember, I talked about this in a previous video. Fermi asked the famous question when we were talking about this. Where is everybody? One of the possible answers to this interesting question, known as the Fermi paradox. As we talked about in that video, the Great Filter Hypothesis. The Great Filter Hypothesis predicts that there are many walls, or filters, that could prevent the emergence of intelligent life. For example, perhaps chemical molecules are very difficult to evolve into living structures and therefore life, even though there are plenty of planets suitable for life. Or maybe life starts easily. The transition from unicellularity to multicellularity, or the evolution of mitosis to meiosis, is very difficult. That's why life always remains at the microscopic level. Or these things are also simple. Organs that can cause intelligence are very difficult to evolve, so intelligent life is very rare. Or the evolution of intelligence is also simple, but before intelligence is sufficiently weeded out of its faults, it blocks the evolutionary process. Therefore, it isolates itself from the selection process before it is free of its diseases and weaknesses, and so it can't be a cover that can exist for a long time. It can't reach the patient. We can go on like this. But this last point is very important. The brain and intelligence we have now is not at the limit of what is biologically possible. The reason why we're stuck at this point is that in human evolution, as in the evolution of every living thing, we have to deal with the environment we're in. That we've developed enough intelligence to survive. And then we use that intelligence to quickly isolate ourselves from the wild, so there's no significant selection pressure on us anymore. But if intelligence can evolve so rapidly in the evolutionary process, if it can then immediately isolate itself from this evolutionary process, perhaps the life that emerges in the evolutionary process never reaches an intelligence that will not destroy itself. In other words, evolving intelligences may necessarily have weaknesses that destroy themselves. This is a chilling possibility. But if it's true, the universe could be a huge graveyard of civilizations rather than a playground teeming with life. Intelligent species like humans can destroy themselves in many ways. The most obvious one is to trigger a catastrophe that destabilizes the planet we live on. And we can do that ... in several ways. Nuclear war is one of them. Atomic bombs, as we've already discussed in great detail. They're just mechanisms that suddenly unleash the enormous amount of energy trapped inside the atom, and the uncontrolled release of this latent energy, atmospheric, terrestrial. It could upset aquatic and geological processes, triggering events such as nuclear winter and the extinction of much of life on Earth. Another such event is human-induced climate change. The climate has always changed throughout the history of our planet and will always change in the future. But as humans, we have accelerated the pace of this change tremendously. What we are doing here is very similar to what happened with the atomic bombs. We are extracting carbon that has been trapped underground for hundreds of millions of years, burning it as fuel and releasing the waste into the atmosphere. So this extra carbon, or the greenhouse gases like carbon dioxide or methane that are produced by its combustion, accumulate in the atmosphere and act like a blanket. The life trapped under this blanket heats up year after year and eventually boils away. In the process, ecosystem. Systems collapse, habitats disappear, and formerly habitable landscapes become uninhabitable. This could wipe out a large part of humanity, perhaps all of it. But the elements that could destroy us don't necessarily have to come from within. Think of gamma ray bursts. These extremely high-energy particles that are emitted when two neutron stars collide, or when massive stars collapse on themselves and explode in a supernova. They can scatter in a few seconds all the energy that the sun would radiate over 12 billion years. Most of the gamma ray sources we have detected so far are fortunately in galaxies billions of light years away from us, and gamma ray bursts in general are a relatively rare event. But this kind of explosion in the Milky Way galaxy, especially if, by chance, it happens to be Earth-facing, it could rip off the ozone layer and the atmosphere in hours and cause an unprecedented mass extinction. Of course, the universe is full of even more terrifying events. This is because the centers of galaxies are the places where black holes are most likely to form and then grow by feeding on the material around them. But black holes are not necessarily located at the center of galaxies. During galaxy collisions, black holes can be ejected at tremendous speeds and hurled into the vacuum of space. And because black holes are impossible to observe directly, even if one were approaching us, it would be very difficult to detect it. Of course, black holes exert a tremendous gravitational pull on the objects around them. We can deduce from these gravitational anomalies that there's a black hole out there somewhere. But here's how difficult that is. Beyond the Kuiper belt, of which Pluto is a part, Neptune, Pluto, and there is something about the orbits of other celestial bodies that causes an anomaly that cannot be explained even by relativity. The orbits of these bodies shouldn't be so smooth, but they are. We are aware of this anomaly, but we don't know exactly what is causing it. One of the possibilities is that there's a black hole that's beyond the 8 planets, but we don't know that it's technically within the boundaries of the solar system. Only this black hole is nothing like the gargantuan interstellar. It's a black hole roughly the size of a grapefruit, what we call a primordial black hole. These are incredibly old black holes, roughly the same age as the Big Bang. But despite their tiny size, they have tens of times the mass of the Earth dot, so if they were to veer off course and cross paths with the Earth, even if they were to pass by us, they can upset orbits within the solar system. In such a case, the Earth could be thrown out of the solar system, which is a good possibility, because as I explained earlier, it's one of the ways to avoid the sun destroying us in 1 billion years or so. It could be to turn the Earth into a spaceship and leave the solar system. But even worse would be for the Earth to enter an orbit in which it would fall toward the sun. Then it could all be over very quickly, but the death from the sky would probably come not in the form of a black hole or a gamma ray, but in the form of a rock. Yes, the kind of asteroid that wiped out the dinosaurs and 75% of the species at that time. We call them planet-killing asteroids. Just last year we discovered one of them, asteroid 2022 AP7, which is 1 to 2 kilometers in diameter, 1/5 the size of the asteroid that wiped out thousands of species 66 million years ago. Its orbit passes 7.5 million kilometers from Earth. That's an incredibly close pass on an astronomical scale, but not far enough for a collision. And frankly, none of the asteroids we are currently tracking pose a significant risk to Earth. For example, among the asteroids we track, the asteroid that could cause the greatest destruction on Earth is a 1.3 kilometer wide asteroid with the code 29.075. However, trajectory analysis shows that the highest probability of this asteroid hitting the Earth is on March 16, 2880, and the probability of impact is only 0.003%. Of course, there may be asteroids out there that we can't detect right now that could pose much greater risks much sooner. But even these numbers are enough to show how short the human lifespan is. We know dozens of gigantic asteroid disasters in hundreds of millions, even billions of years of Earth's history. But when we look at it over a period of a few hundred years, everything looks so calm and ordinary. Being complacent is probably the biggest mistake our species can make. And at the same time, this stagnation has caused our planet's average temperature to rise by an incredible 1.1 degrees Celsius in just 150 years. That we've been able to increase the number of robots in the world. Malicious artificial general intelligence, Terminator robots, which could of course lead to the extinction of humans in the much nearer future. Nanotechnology, biological weapons, and pandemics. But since these are now very cliched topics, I will not go into details here. In the future, I would like to tell you about them from more original perspectives. Let me just say this. Pandemics aside, things like artificial intelligence or biological weapons were unimaginable just a few centuries ago. This shows us a very frightening reality. In the coming centuries, we are going to change the world. Imagine what we'll learn about physics and nature. It won't all be rose gardens and butterflies. We will also discover many truths that are absolutely terrifying. And some of them will be truths that could lead to our doom and ways, and at speeds we never expected. So we need to strengthen science, our only tool to uncover these truths. Finally, I would like to make a reference to the great comedian George Carlin. We associate ourselves so much with existence, or with the Earth, that we believe that our extinction will be the extinction of the Earth and even the universe. Even though some of the scenarios we discuss in this video could lead to the extinction of the entire planet, or the extinction of all life, human existence is far more fragile than we realize, and the existence of the Earth and life is far more resilient than we realize. So events like a climate crisis or an asteroid could wipe out tens of thousands of species, including humans. But the Earth has seen many versions of these in its 4.5 billion year history, and will continue to do so. And as Carl Sagan said, life will probably always find a way. So in all these scenarios and many more, the most important thing to understand is this. If we are not careful, we, an ordinary mammalian species, armed with extraordinary intelligence, will disappear. But life and the world will go on as if nothing had happened. The world and life don't need us. We need them. The sooner we realize this fact, the sooner we can focus on the questions that matter and stop bickering over hypothetical problems. See you in the next video. Goodbye.